Okay, so we're going to start with a note-taking method that is super effective in mathematics. Because we don't have much time, you need to have your work as organized as you can so that you can look at things and go back and really study this. And this method is often called the Cornell system. You might have heard of it. I don't know if any of you been taught note-taking methods before? So again, I don't know what you're doing. So what you're going to do is you're going to have your paper, right? And I want you to divide it in half. And you can do that any way you want to. Some people fold it over, whatever, draw a line, doesn't matter to me. But you're going to fold it in half. And on this side, what you're going to do is you're going to take your notes. Now, when I mean notes, what I mean is I'm going to give you methods, steps for the processes, right? And I am very methodical, which you might have noticed. So I'm going to give you step 1, step 2, step 3, etc. on how to do something. So I'll always explain it about how we're going to work on it. Okay? Then on this side is where you're going to write your examples. Don't think that, and traditionally what you do is you put your examples in your notes if you're taking notes at all. And what happens is they get all cluttered and you can't really tell the difference and it really hinders you later. Another thing is, and when you're going to do this is you're going to write, so I'm going to have some kind of introduction to a topic, and then you're going to do the example here next to the steps. So there's going to be a lot of blank space on that side with the examples. 2 reasons why. First of all, the steps, the process, that's what you study. Have you been to Hamilton? I don't know. I'm just thinking. All right. Could you tell me how to get there?
Yeah.
Sort of. Okay. Does that mean I'm going to get there? Okay. All right. Can you tell me how to anti-differentiate something? Can you tell me? Could you teach it to me if I didn't know?
No.
Then you don't know it. See what I'm saying? And it's that process. It's the steps that you need to know. Okay? Think about someplace you go all the time. Okay? You get to school all the time. The very first time you came here, well, you might have been 6, I don't know. But the very first time you came here, you might not have known where it was, right? Or think about any place you've ever gone where you didn't know where you was. So you got out your phone and you let Google Maps tell you which turns to take, or you wrote down directions or something. So did you look at it once on your phone and then never look at it again?
Yeah.
And you could get anywhere in New Zealand?
Not anywhere, no.
Somewhere where you've never been that's complicated, right?
But some places you can.
Some places, yeah, but we're just think about some place where you have it. Instead, what you do is you follow those directions as you do it, yeah? Then the next time you do it, you might not have to follow the directions, every direction, but you still like to have those things handy, right? But then what happens after you've done it over and over? Yeah, many times you don't even know. Like there'll be times I drive to work and I'm like, oh, look at that, I'm here, right? So it's important that you understand the processes in the mathematics that same way. And so those processes, those methods and steps are the things that we need to study. Those are the things that are going to make you comfortable, right? So think about like when we did the paper we just did. We didn't talk about the numbers as much as we talked about what is it that needs to be included, right? And then you went and you got your numbers, right? So you're going to think of this the same way. So that's how we're going to work with this. And so I want to talk to you about factorizing, and we'll talk and just as an example, so you can see what I'm talking about and how to write it and how to deal with it. Okay. So we'll talk about factoring. So again, just divide it in half. We're going to talk about factoring polynomials with 3 terms. Okay? Because those are the ones that I saw on your test. I didn't see anything else other than those on your test. But I saw several of them where you had to factor them, right? And I'm sure you've had factoring in your past. I'm just kind of getting you back into the swing of things. Remember that we say they have three terms because you have some ax squared plus bx plus c. And remember that every time you see a plus or a minus, you know that that's the beginning of a brand new term. Right? So you can always tell where one term stops and the next one begins every time you see a plus or a minus. Because those are the first parts of every term, with those signs, those pluses or minuses. So this polynomial has three terms. And there are lots of different ways of doing it. And the most popular one, at least in the States, is a method called FOIL, which is just basically glorified guess and check. But what I'm going to show you is something called the AC method. Have you heard of that one? It may.
Like add A and C together or like times.
You multiply them together, right? So it's piece by piece. You're going to turn something with three terms into something with four terms, and then just look for the greatest common factor. So I think some of you were familiar with it when we looked at it on the board. So if you look at my example here, just the general form of the trinomial that I have here, the polynomial with three terms, I have an A and a B and a C, which are in front of those numbers. You're really familiar with that because most of you did pretty well on the ones where you had to use the quadratic formula, right? And you had to pick out your A and your B and your C. So you're very familiar with where those come from. Well, the AC method uses those same letters, that same kind of format, to be able to factor. So the first step is to simply multiply A times C. When you're doing that, watch out for the signs. Be really careful and include those signs in there. Because if you make one sign error, then everything's gone. So be very careful with them. In the second step, there are a couple of pieces. We want to, Now let me write it a little bit different. List factors, and remember factors are anything that divide in evenly. Factors of AC. Now AC is just what you got when you multiplied A times your C, right? AC literally means A times C. So that's that product that you got on your first step. Until you find the two that will combine to make B. Combine means either add or subtract depending on their signs. Okay? And B just means that number that's in the middle of it, right? So you remember where the A, B, and C come from. Okay? Now don't worry if you don't want following right now, because we will do an example so you can see each piece of this, but I want to see it with the steps. All right. Third, you're simply going to rewrite the B term using those two factors. Right? So instead of 7, I might have now 3 and 4. Right? You're going to rewrite it as two pieces using those two factors. Okay. Don't forget the variable, though. It's going to have an X or an A or a whatever in it. Well, they need to have an X or an A or whatever. Okay? So don't forget the variable. Hopefully we have some examples here. Okay. Next, separate into two sets of two terms. In other words, you're going to break it in half. Because you don't have 3 terms anymore, you have 4 terms. And you're just going to break it in half. Find the GCF, greatest common factor. Do y'all call it that here? Greatest common factor. That means the biggest thing that'll divide evenly into something, right? Find the GCF. In the first pair. There'll be something that divides into them. So like 3, you might have 3 and 6, so they'll both divide by 3. Whatever will divide into them. Next, bring down the sign of the third term. Whatever sign that is, it just comes straight down. It's the sign you're going to need. Most of the time when you're taught this method, you're taught to, try this sign, try that sign, just bring, and then figure out which one you need. You don't need to do that. It's always whatever sign that third term is. Just bring it straight down. And again, I'll show you an example of this in a minute. Then, find the GCF in the second group, the second pair of terms. Even if it's only a 1. We have to divide something out of it, no matter what. Now remember, when you divide out a GCF, say for example you have 6x plus 2, what's common to 6x and 2? They're both divided by 2, right? So then you put that 2 in front of a parentheses, and then you go back and divide. 6x divided by 2 is 3x. Positive 2 divided by 2 is positive 1. And then you close it off with a parentheses. Remember that? So anytime you take out a GCF, you end up with a set of parentheses. And the thing that's important down here is those parentheses that you get, because you're going to get 2 sets of parentheses, they must match. If they don't, then either it won't factor, which means you have to resort to the quadratic formula, but there were some on there where it said all you had to do was factor, so you knew those would factor, right? And then if they don't match and it says factor it, then that means you've done something wrong, right? So go back and figure out what it is, okay? And so here's how you're going to write your answer. Okay, now I'm going to write this in general form. Don't put X there, put C, sorry. And this is not your A, B, and your C from the others. This is just using random letters, the alphabet. So, can't do that because I just told you those two have to match, right? So these both have B plus C in them. Let me rewrite that so that looks more like a C. Oh, come on, really? So do you notice that the 2 sets of parentheses match? And they have to. So your final answer is just B plus C times A plus D. Or you can reverse them if you want to. Most of the time, books will reverse them. I don't know why. Order doesn't matter when you're multiplying, does it? 2 times 3 is the same as 3 times 2. Okay? So that's the process. Now, I may use a lot more steps than you're used to. And you may not be used to thinking of things as a process like this as steps anyway. But some things, especially algebra, is just a set of algorithms, a set of processes that you apply to every single problem that's like that. So if you know the rules, then you can always go to those rules and apply them. And if you have those rules in your head, then you're never going to have that, okay, I'm not sure what to do here feeling. And that's why separating them on your notes makes a big deal. So let's look at an example. Okay, so on page 51, number 7. So really, let's be going back here. Right by the steps is where you should do the example. But that way you can refer back to the steps and the thing, and then later when you're trying to, I actually changed, I picked the wrong one, but it doesn't matter, same difference. So when you have your examples next to it, especially when there's no other clutter over there, if you're doing something, like you're doing something in your homework or you're studying something, you can look down and find the example that looks like it and where are the rules for how to work it. Right next to it. Yeah? But if you have to dig through all your notes to find the example, how likely do you think you are to do that? I don't do it. Most people don't do it. So the more organized you are, you can be, the better. Okay, so first thing I need to know how many terms it is. 1, 2, 3 terms, right? So we're going to use the AC method. So what is the first step in using the AC method?
Multiply A and C.
A and C, right? And here we have, and notice it's ax squared minus bx plus c. So my a in this case is the 4, and my c is the 2. 4, don't you like how many syllables that had? Sorry, my texting is coming out. Which gives me an AC of 8. Right? No big deal there. Just multiply the first number times the second number. Don't worry about the letters right now. Then, we're going to just start thinking of factors of 8. Factor just means anything that'll divide in evenly. And when I do this, I always just start listing them in order. So 1 goes into 8 times. But if you add 1 and 8, you get 9. Remember, I'm trying to make this middle number there. Is 9 what I'm looking for?
No.
Nope. If I subtract them, I get 7. Is 7 what I'm looking for?
No.
Nope. Then that ain't going to work. So 2 goes into 8 4 times. If I add 2 and 4, does that make 6? Yes. Right? So I need to add them. Well, what do you know? But I need to add them to get a negative 6. So do the signs need to be the same or different? The same, right? So it has to be negative 2 and negative 4. And that's the hardest part of this whole thing, is just deciding which 2 numbers to use and what signs they need to be. The next thing I need to do is remember that it wasn't just a plain old 6, it was negative 6 what? So they both need to have an x in them. You don't want to do it you don't want to include it when you're doing your math, because it gets really cluttered. Okay? Then I'm just going to rewrite it. Just bring down the other 2 terms. They didn't change. We used them to find those. And I'm going to break it in half. Right? So separate it into 2 sets of 2 terms. So that's what this is doing. I'm separating it into the first 2 terms and the second 2 terms. Second 2 sets of terms, 2 groups. Then find the GCF in the first pair. Okay? So all I did was separate the 2. So you got your 2 new numbers, right? And then the A and the C are just going to come straight down unchanged. So now I have not 3 terms, but 4 terms. The B term is the only one that changes. Okay? Then I'm just going to find the GCF in the first group. So, right here. What's common to 4 and 2? 2. What else do they have in them both? X. So the GCF is 2x. Look at the number first, and then look to see if they both have an x in them. Now divide. 4 divided by 2 is 2. X squared divided by x is x. Negative 2x divided by itself makes what? Negative divided by positive is a negative, and anything divided by itself makes a 1. This sign always just comes down, never changes. What's common to 4x and 2? 4 and 2 are both divided by 2. But remember, I have that negative down there, so what am I really dividing by? Okay, so negative 4x divided by negative 2. Negative divided by negative is positive. 4 divided by 2 is 2, and x divided by nothing just stays x. Now we'll do this part. Positive divided by negative is negative, and 2 divided by 2 is 1. What do you notice about those 2 sets of parentheses I just got? And they have to be. So I'm going to get 2x minus 1, and then the other 2 pieces just go in the second parentheses, and there's your factored form. It's process. These are the hardest type of things you're going to factor. But it's not a terrible process. And it puts together pieces that you've already done. Because hopefully you've done factor by grouping, which is this part there. And hopefully you've done well, you've had to have done GCF or else you couldn't have done any factoring at all. Okay? So, that's the kind of thing that I want to work with you on, is I want to go through and give you some steps and processes for dealing with each kind of problem. I also want to talk about why we know that something is a particular type of problem, right? So when we're going through those tests. So let me go over there next door and see